A vector is an arrow in a vector space which is defined by orthogonal directions. These directions are arrows with a unit length of 1, and them being orthogonal means that they are at right angles to each other. It is easiest to work in 2D and then easily extend our ideas to 3D. In 2D, we have two orthogonal directions, indicated by these basis vectors, which are commonly called I and j. A vector in this space is simply an arrow drawn. We have two ways of describing an arrow in this vector space. One is by saying what combination of the two basis vectors will form the arrow, and we call this the component form. Here we see that this arrow is equivalent to 4 of the I arrows and 3 of the j arrows. It is important to remember that I and j vectors are positive in the indicated directions, and so a negative I vector looks like this. For example, this arrow would be -4 of I and 3 of j. The other way to describe this vector is by stating its size, its magnitude, and the direction that it is pointing in. The size of this arrow can be found from our I and j description. Since I and j are unit length, this vector forms the hypotenuse of a right-angled triangle with sides 4 and 3. The size of the vector is then found by doing the square root of 3 squared plus 4 squared, which is 5. To indicate its direction, similar to I and j, we want to find a vector, which we will express in terms of I and j, that has a unit size of 1 and points in the direction that the arrow is pointing. Well, we know that this vector points in the direction that we want. The problem is that it's too big. It currently has a length of 5, and so to chop it down to size, we must divide the thing by 5. The vector can then be expressed as the magnitude of it, multiplied by the unit direction vector found by dividing the original by its magnitude. This magnitude is found using Pythagoras. Instead of finding the direction vector, we could just indicate the angle that the arrow makes with some axis. For example, the angle that this vector makes with the positive x-axis is found by doing the tan inverse of 3 over 4. To extend into 3D, we need only include another orthogonal direction which we call k, which slightly modifies the Pythagoras equation.